Hello class, this is the solution for the exam type A. I'm going to be solving each of these exercises completely so that you can see how they were solved in case you could not do any specific one. I'm going to be putting timestamps on each exercise on the YouTube video, and that's about it. So let's begin. The question number one is this: solve the following exponential equation, and then I give you a hint or a clue. It's better not to use logarithm base 10. Try using another base to solve this problem. This was just a suggestion, okay? You can work out this equation with any logarithm. And what I mean by any logarithm is any base, whether 10, 8, doesn't matter. But it's advisable, in this case, it's advisable to use logarithm base 2. And the reason for that is this, guys. If you notice here, these two numbers, 1/2 and 8, are actually powers of 2. 1/2 is 2 to the minus 1, and 8 is 2 to the 3. And by using logarithm base 2, I can, have some sort of simplification with this equation. Even though this is a perfectly good logarithm to use, I'm gonna use both so that you can see how it works. So let's do it. So let me write down the equation over here. There you go. And I'm gonna begin. I will begin by applying, by taking the logarithm base 2 of both of these two expressions. So basically this logarithm base 2 of this of my left side equals logarithm base 2 of the right side. Okay, it's perfectly possible. And then I began using my laws of exponents. I know that the logarithm base whatever of some number raised to some exponent, what I can do with this is simplify by lowering the exponent like this. X minus 1, that multiplies logarithm base 2 of 1/2. And I'm going to do the same over here. I can lower this exponent like so. There you go. And this is where, at this moment, you can see the usefulness of using logarithm base 2, specifically base 2. Why? Because, like I told you before, these two numbers are actually powers of 2. So you can calculate this and this quickly and without calculator, without anything. It's very simple. All you have to do is remember what this means. Logarithm base a of x equals y is the same. If you put it in exponential notation, it's the same as a to the y equals x. You remember this? These are equivalent statements. There you go. This is completely equivalent to this. Completely. They say the same thing. So basically, if I want to calculate the logarithm base 2 of 1/2, and I say that the result is r for result, I'm just labeling this result r. Then if I put this in exponential notation, I get 2 to the r being equal to 1/2. And like I told you before, 1/2, you know that 1/2 is 2 to the minus 1, right? And that's it. Therefore, r equals -1, and therefore all of this is just equal to 1. I'm sorry, -1. So that's it, guys. I can make that substitution here. All of this is going to be equal to -1, like this. There you go. And the same can be done here. Logarithm base 2 of 8. But when you do the same thing, you can replace it for 3. Logarithm base 2 of 8 is 3 because 2 to the 3 is 8. Okay. And that's it, right? I mean, this is just now a linear equation. Can be solved very quickly, very simply. Since I could stop right here, but I want to have completion. So let's just complete the whole thing. Let me multiply. We get this being equal to this. And then we have 4 equals 7x. And then we have x equal 4 over 7. And I'm done. This is it. Okay, this is the whole solution for this problem, x equals 4/7. Now, how can I do the same thing in logarithm base 10? Let's try that out. I want to convince you that you can use any logarithm. Logarithm base 10, logarithm base 3, logarithm base 27. It doesn't matter. It doesn't matter. And I'm going to convince you of that. I'm going to write the same thing. 1/2 to the x minus 1 equals 8 to the 2x minus 1. And now I'm going to apply this, logarithm base 10. I've been telling you that logarithm base 10 is for historical reasons, and the fact that we use a decimal system or a numerical system on base 10, this is very common. This is the one that your calculator has. But there's nothing really special, guys, about this logarithm. Nothing really special. I mean, probably the special thing about this is that we have 10 fingers, right, on our hands, and that's what makes it special in a way. But other than that, there's nothing special about logarithm base 10. It's just that. So let me use that. Let me use logarithm base 10 of this left side. It's going to be equal to logarithm base 10 of the other side. There you go. Since I am dealing with logarithms of a number raised to an exponent, I can apply the same trick, lowering the exponent in this way, like so. Okay, I can do this. Now the problem is that I cannot calculate logarithm base 10 of 1/2 quickly or directly or without calculator. That's the problem in quotation marks. And neither I can calculate this. So let's continue. I'm gonna do some algebra here. I'm gonna write this. Okay, I can do this. And I'm sorry, by the way, I should do this. Okay, like this. And now, well, even though you cannot calculate the logarithm base 10 of 8 and the logarithm base 10 of 1/2, what you can do instead is, well, kind of like another trick, which is this. It's the same thing I told you before. Try to express these two numbers. Since you know, or you should know, that 8 and 1/2 are powers of 2, 8 is equal to 2 to the 3, and 1/2 is equal to 2 to the minus 1, then it's very advisable to write these two numbers in such forms. And you're going to see why in a moment. Okay, logarithm base 10 of 8 is equal to this. Because of this, right? Then we continue. X minus 1 over 2x minus 1. And then, once again, I apply the same trick I applied here. Since I have the logarithm base 10 of a number raised to an exponent, I can lower the exponent. And then you will have this. And the same in here. 10 of 2. And this is where the magic happens, right? If you can see, now we have 3 times this number over minus 1 times this number, and these two numbers happen to be the same. Therefore, we can just simplify. And basically, all of this stuff goes down to minus 3. There you go. So basically, now we have this equation. This equals minus 3, and from here you can pick it up. See? So my idea was to make you realize that you can also use logarithm base 10 or any other logarithm. It doesn't matter. Now you may be thinking, okay, what if I cannot apply this trick of putting these two numbers into the powers of a given same number, in this case 2. For example, what if this was 5? What if this was 5? Okay, well, what you can do simply is just keep this number. Let me keep all of these guys as a constant. Just label it. Like say this. Consider logarithm base 10 of 8 over logarithm base 10 of 5, and just give it a name. Give this a name. I'm gonna call it k, and k is a constant, right? It may be difficult to calculate in decimals without calculator and stuff, but it doesn't matter. This is a constant. Okay, it's just a number that you know the value of, even if it's hard to calculate. So just call it k and just do this trick. Then we have x minus 1 over 2x minus 1 being equal to k, and just pick it up from here. Just solve this equation, and considering that k is not a variable, this is not a variable, it's a constant. It's a constant, okay? Think of this as if it was the number 3 or something, and just basically solve the equation in terms of k. And at the very end, when you're done doing the whole algebra and stuff, then at the end, go back and replace k for what it truly is, which is this, and that's it, period. Period. There should be no complications about this. I hope you understand this. If you don't, you can, as always, send me a message through inbox if you want me to clarify what I mean by this. So that's it. That is the problem number 1. As you can see, I'm taking a lot of time to explain to you many things. How much time did this take me? You see, 12 minutes. But I'm doing them very carefully with a lot of explanation, even trying several possibilities for each problem, etc. Because I want you to not only understand the problem, but like really, I want you to more than understand the problem. I don't know if that's possible, but I don't know. I want to explain more than usual. That's what I mean. Okay, let me make a pause. I'm gonna be making pauses between each problem, and then we continue with the next one. Okay, the second problem. Solve the following logarithmic equation. Leave your answer in exact terms. What this means is don't don't even attempt to calculate stuff like this, like logarithm base 2 of 3. Like, no, just keep this number. Just keep it like this. There is no use in trying to calculate this as 0. I don't know, whatever. Or when I tell you, like, if you got the solution for a certain equation, x equals the square root of 2, if I tell you leave it in exact terms, this is what I mean. Like, don't try to approximate this to 1.4 blah blah blah. Just keep it like this. There is nothing wrong. There is nothing wrong, and this is in fact what we understand by the exact solution. So what is the equation? It's this one. Let me copy. Logarithm base 10, right? Remember that when you ignore the base in a logarithm, we are talking specifically about base 10. And that is the only base for which we can do such a thing. Okay, So this is the equation. Let's begin. I'm gonna do this. I'm gonna bring my terms with logarithm to one side. And I'm gonna put all the constants on the other. There you go. Then I have this law, logarithm of a times b. Sorry. Well, I'm just gonna write logarithm of a times b like so. This is equal to logarithm of a plus logarithm of b. And I can work in reverse. If I know this, then I can go to this, right? Like you can either see it from here to here or from here to here. It works in both ways. And if you notice, the form that we have in all of this left side is this one, right? The same logarithm in the same base, they have to be the same base. Do you notice that? They have to be the same base. If you have different bases, like say 2 and 3, you cannot apply this any type of simplification of this. It has to be the same base. Any base, but the same base. So since that's the case in here, then I can write this addition as the logarithm of this number times this number. And that's what I'm about to do. There you go. Equals 1. Okay, perfect. Now, once again, what does this mean? What does this mean? That the logarithm of certain number equals 1. The logarithm base 10, by the way. Well, that means, let me actually write down the base. Logarithm base 10 of this equals 1. This is equivalent to saying that 10 to the 1 equals the number. You see? And since you need to understand what this means, guys. This is equivalent, okay? Like what this symbol tells you is that all of this thing, in this case, an equation, right? All of this equation is completely equivalent to this equation. What that should tell you is that if you solve this equation, that would be as solving this equation. You see? And look at this equation. It seems pretty simple to solve because 10 to the 1 is just 10. And this is a product of conjugated binomials. When you multiply these two binomials, you get x squared minus 1. And this equation is very simple to solve. We get x squared minus 1 equals 10. We get x squared equals 11. And then finally we get x equals plus minus the square root of 11. Now, if you remember, guys, if you did this, I should have checked your second exercise as correct, whether you put the plus minus or just the plus. Some of you only put the plus like this. I don't know if you did it with like with I mean, this is in fact the right answer, not with the plus, for the reason I told you before, that we cannot evaluate logarithms in negative numbers. If you don't remember this, don't worry too much. I told you that we were going to take a look at this detail, that the logarithm of a negative number does not exist. And I'm going to explain to you why. So if you consider the negative of this root, how much is this root? It's about 3 something, right? I mean, the square root of 11 is more than the square root of 9, which is 3, right? So this is a little, this is, let's round to minus 3. Let's just round. Let's suppose this is minus 3 plus minus 3. Okay, instead of this, we have plus minus 3. I know it's not the same number, but I'm just rounding. And if you put minus 3 in either here or here, you would be basically having negative numbers inside the parentheses, right? Minus 3 minus 1, you get minus 4, and minus 3 plus 1, you get minus 2. And that would break. That would break the logarithm. Okay, why? Because logarithms cannot be evaluated in negative numbers. I will explain that in due time. When we analyze this specific function, the logarithmic function, we will see why this is not allowed. So whether you put the plus and minus, or whether you just put the plus, that's correct. That's correct for the moment. And that's it. Okay, that's how you solve this problem. So let's go for a pause and we come back. So next problem number 3. The following is an equation representing a straight line. This is the equation. And I'm giving you several instructions, or I'm asking you several questions. Rewrite this equation in the form slope intercept, etc., etc. Five questions. So let's go one by one. Let me write down the equation. There you go. And let's rewrite it in the form slope intercept. What is the form slope intercept? This one. This is the slope. This is the intercept. What intercept? The one with the y-axis. This one. That intercept. So let's do it. This is pure algebra, so I'm not going to be explaining anything. Just follow the algebra. If you notice, we need to have the y on the left side and all the other stuff on the other side. So basically, it's basically this instruction, guys. It's basically the same as telling you isolate y. It's the same for practical purposes. So I'm gonna bring everything to the other side. We have this. There you go. Let me clean this up a little bit. We have 2x minus y plus 3x minus 3 plus 3 minus x. Then we have this, and this. These are like terms. We have for x, and we have this, and this like terms. This boils down to minus 1. And finally, we just divide both sides over 2. There you go. You can leave it like this. It's perfectly fine. Although, since you can actually divide 4 over 2 perfectly, let's do it, right? Y equals 2x minus 1 half. Either way, either this or this, they are the same stuff. So that would be the first question. This is the equation. Either of these is the equation, which is the same as this, but in slope intercept form. Okay. Then B, rewrite this equation in general form. So for the general form, remember we have this ax plus bx plus c equals 0. This is how the general form of a straight line looks. Some constant multiplying x plus some constant multiplying y plus some constant being equal to 0. So basically just bring, I mean, if you already have this, just bring all the sides to the left side, and you can have this minus 2x plus y plus 1 half equals 0, and that's it, right? That's it, because now this looks like this. Some constant times x plus some constant times y, the constant is 1, plus some constant. That's it. Now, maybe you have this, like 2x minus y minus 1 half, and that would be also okay, right? Because if I multiply times -1 in both sides, that would be okay. And in fact, I mean, either this is good or this is good, or if you pick it up from here, guys, like if you start with this equation and you just bring everything to the left, you're gonna have something different than this, something that looks different. That's what I mean. And it would also be correct. It would also be correct. What you need to understand is this. Realize that I can multiply this equation by any constant and it will still be in the general form. Do you want me to try it out? For example, take a look at this. Let me multiply by 3 on both sides. I'm going to pick both sides and I'm going to multiply by 3. Why? Because I want to. Because it's perfectly valid, right? And I'm going to have 6x minus 3y minus 3 halves equals 0. Take a look at this. Is this equation looking in the general form? Yes, absolutely. So this also classifies as the general form. Either this or this or this or any other equation that you can get in the same, doing the same process, multiplying both sides by a given constant. It would work perfectly okay. Find the x-intercept. In order to find the x-intercept, let me write this in here. Find x-intercept. Okay, what is the x-intercept? The x-intercept is the following. If you draw your line, let's imagine that the equation of this line looks like this, in this direction, etc. We're not sure, we're just making believe. It doesn't matter. So this is the y-intercept, this is the x-intercept, and y-intercept. They're asking me for the x-intercept. What feature does this point have? What feature? Well, the feature that its y-coordinate must be 0, right? All the points along the x-axis, all of these points have this coordinate for y, 0. And the other coordinate, that's what we mean by the x-intercept. You see, it's the value at which this line cuts the x-axis. This is the same as this, and the other coordinate should be or must be by necessity 0. So that's it, guys. This is how you find it. If you already know that the y must be 0 in order for you to find the x-intercept, then just choose the equation 2x minus y minus 1/2 equals 0. Choose it or write it down. Give y the value of 0, and by doing this, you would be finding the value of x. In other words, when you give y the value of 0, you will be finding, let's actually do it. There you go. Let's solve the equation now. 2x equals 1/2, x equals 1/4. I'm not gonna go into the details of the algebra. X equals 1/4. That's it. So that is this particular coordinate. This is a 1/4. That's it. And thus this is the x-intercept. This one. Okay. Let me erase everything. Then D and E. Well, let me bring it back for a moment. No, let's just bring it back. So now we know what the x-intercept is. Now let's find the y-intercept. That is even easier because you already have this thing, right? What is this? This is a slope-intercept form. Slope-intercept form. And that's it. What information does this form give you? It gives you the slope, which is 2, and the intercept, which is minus 1/2. You have to pick the number and its proper sign. And what intercept is this? I told you this is the y-intercept. When we're talking about lines and I just say the word intercept, what I mean, and not only I, but any other mathematician in the world, what we mean is the y-intercept. This is the same as the y-intercept, okay? And if you want to make reference to the x-intercept, you necessarily must say x-intercept. So that's it, problem solved. Find the y-intercept, it's minus 1/2. And find its slope, same stuff, right? Just look at this, observe it, analyze it, and we have that this is the slope, so my answer should be 2, period. Problem solved. Problem number 4, we have this. The following are the equations representing two lines, line 1 and line 2. This is my line 1, this is my line 2. I want to explain to you something about this, guys, just in case I didn't formally explain it. Look, this is the equation representing line 1, this is the equation representing the line 2. And if you notice, I put this L1 and then a colon, and then L2 and another colon. We usually do this in mathematics. Like if you have equations that are representing objects, in this case, these two equations represent two lines. Okay? And you are giving names to both lines. This is line 1, this is line 2. You can do this, what I just did here, like you're making reference to line 1 as being this one and line 2 as being this one, but you are not allowed to do this. Like you should not put that L1 equals 3x plus y equals 6x minus 1. This would be very weird. Why? Because by doing this, you're kind of like saying that L1, like this symbol, represents a number. You see, you're saying that this number equals this number, all of this number, which equals all of this number. And that would be incorrect. This is a name. It's a label. It's a label. You see, so it's much more advisable, much more advisable to write colon instead of equals. Using equals would be, I mean, it's just a no-go. Just don't do it. Do it like this. When you're writing this, you're saying my line 1 is this equation. You see, this is much better. That's the only remark that I wanted to tell you about. Okay, so I have two lines. Let me copy them. 3x plus y equals 6 times x minus 1. And we have another line, ky minus x equals 5x plus 2. And they're telling me that the number k is a constant or a coefficient. It's just a number that you know. Well, I mean, in this case, that's kind of like a contradiction, right? I'm telling you, we don't know this number so far. Okay, let me explain what I mean by this. K in this equation should not be considered as a variable. Okay, this is a value that, let's say that a friend gives you this equation. It tells you, hey, you know what? I have an equation, ky minus x equals 5x plus 2, and k represents a number that I know, but I'm not going to tell you. You see, like this number is known, but not exactly by you. Let's say that it's hidden from you, even though it's known. It's kind of like hidden for you. You see, so what do you do? You cannot write any name, and I'm sorry, you cannot write for k any value, because for example it could be 3, right, or it could be 1/2, or it could be anything, but it's hidden. You don't know it. Some other people may know it, but you don't. So what do? You write a variable like this, okay, or a symbol to represent this constant. Okay, and that's how you should treat this. Like you should treat it like kind of like pi, kind of like that, more or less. I know it's a little tricky to understand. It's just a number that is known, but not exactly by you. Like you don't know it so far. You don't. Okay, so we have these two lines, and I already told you what k means, and I ask you two things. The first is find the value of k such that L1 and L2 are parallel. So let's do that. How do I know whether two lines are parallel? How do I know that? The test for parallelism is that both slopes are the same, right? The slope of the first line, represented by M1, should be equal to the slope of the line 2, which is represented by M2. So if I know that this is the case, then these two lines are parallel. So let's investigate. Let's investigate the slopes of these two lines. How do I do that? What I do is I'm going to put each of these two equations into the slope-intercept form. The slope-intercept form, because that form will tell me the slopes of each individual line. So let's do it. This is L1, this is L2. So let's do that. I'm first gonna work with L1. I mean, you don't have to be writing L1 every single time. Let's just work with the equation. Okay, this is it. This is line 1 in slope-intercept form. What can I conclude? I conclude that its slope is 3. Okay, now let me do the same for the second line. I'm gonna write it down. Ky minus x equals 5x plus 2. Then I can do this. I divide this term over k and plus 2 over k. And then I told you that, I mean, you should know that this can be put into this form. 6 over k times x plus 2 over k. There you go. And now you can see that I have put my equation given originally into, once again, the slope intercept. This equation is in the slope intercept form. What is the slope? This is the slope. The slope is equal to 6 over k. What is the intercept? This is the intercept. The intercept is equal to 2 over k. You see? And I mean, you may be thinking, well, we don't know the slope because we don't know k. And I get your point. I mean, all I can say at this moment is that the line 2 has a slope 6 over k. That's it. That's all I can say. And until I know k, I will be sure exactly of how much M2 is. At the moment, all I can say is that the slope 2 will be equal to 6 over k. Whatever number k is, it's going to be 6 over k. That's it. And that's why the problem is phrased in this way, guys. Find the value of k such that L1 and L2 are parallel. If I want these two lines to be parallel, then I must have that M1 equals M2. What is M1? M1 is 3. What is M2? M2 is equal to 6 over k. So if I want these two lines to be parallel, I should be having this in blue I should be having this. In other words, I should be having this. In other words, I should be having uh, I should be having this 6 over 3. I'm not going to do the algebra. You work out the algebra. Okay, that's very elementary. So k must be 2. And the problem is solved. K must be 2. You see? B. Find the value of k such that both lines cut the y-axis at the same point. Okay? So let me erase this. You see, since I already have L1 in my slope intercept form and L2 also in my slope intercept form, I can dispense with this. Please ignore this. This is just a reminder for me. I just thought of an idea and I don't want to forget it. Just ignore this. So find the value of k such that both lines cut the y-axis at the same point. What does that mean, guys? What does that mean? That means the following. If you put the Cartesian plane and if you drew both lines and if you want them to cut the y-axis at the same point, let's say right there, then what you would be saying is that they're going to have the same y-intercept. That's it. That's all this statement is telling you. It's telling you find the value of k such that both lines have the same y-intercept. That's it. That's it. And how do I do that? I look at the y-intercepts. For L1, the y-intercept is minus 6. I'm abusing the notation here, okay, because L1 is not this, but you heard me, so there should not be a problem. And the intercept for line 2 is this. And if I want them to have the same intercept, then clearly I should have that minus 6 should be equal to 2 over k. And therefore, I should have that k is equal to 2 over minus 6, which is minus 1/3. And that solves the problem. So k must be equal to minus 1/3. And that's the solution for this problem. Problem number 5. And this is kind of similar to the previous problem. So let's see, problem number 5. The following are the equations representing two lines, line 1, line 2, same remark that I gave you before. Like write a colon, not an equals sign. And well, let me write down the equations first. The line 1 is 3y plus 2x minus 1 equals 2. And the line 2 is 2y, 2 times y plus 1 minus x equals 2x. So these are my two lines. What are the questions now? These two. Determine whether these lines are parallel, perpendicular, or neither. And B, find the distance between their y-intercepts. Okay, the method of solution is pretty much the same as before. Like, what I want to do is put these two equations into the slope-intercept form. That's the first thing. Like, put these equations into slope-intercept form, which I'm about to do right now. So let's do it. Once again, I'm just gonna shut up and do the algebra for you. There you go. This is this is the slope-intercept form of this particular equation, which is the line 1. And I do exactly the same stuff for the line number 2. That's it. That's it. So I'm I just uh, I just wrote the slope-intercept forms of these two equations. Okay. So what information do they give me when I observe them and analyze them? Well, if this is equation 1 for the line 1, I can readily see that the slope is minus 2/3. And when I observe the same feature from the second equation, from the second line, I realize that the slope is 3/2, right? And therefore, since I know, or I should know, that the test for perpendicularity is that the product of the slopes should be equal to -1, let me try it out. Let me try it out. Is this times this, and 1 times m2 is equal to minus 2/3 times 3/2. That's clearly equal to -1. And since the test was passed, that means that these two lines are perpendicular because of this reason. By the way, guys, you should argue. Like, I mean, if you didn't do at least like 60% of what I just did, or 70%, I cannot give you the whole mark. Okay, because I need to see this process, and not just me, but the IBO. When you take your papers at the end, they should see this type of reasoning, because otherwise, how are you finding this out, right? So you should have it. You should have it. Okay. Now find the distance between their y-intercept. This is where oh, no, it's perfect. No, there's no mistake in here. So let me write this part here. So what does this question mean? It means this: if you drew both lines in the same Cartesian plane, then you can observe that the first line, which is this, has an intercept of 1. So this is the number 1, this is the number -1, 2, -2. So this line has this y-intercept. There you go. This is the y-intercept of line 1. And line 2 has this y-intercept, which is -1. And that's it, right? I mean, we don't care in what direction they are. I mean, we all know, I mean, we only know that they cross the y-axis at these two particular points. So what is the distance between these two intercepts? Well, it's just 2, right? 1, 2, period. So they are perpendicular, and the distance is 2. Problem solved. We continue with problem number 6. Given the function f of x equals 2x squared minus x, I give you one function, and then I ask you a bunch of stuff. I think I ask you 8 questions or 7. about this particular function. So first, I want you to find some evaluations. Remember, these are called evaluations. In this case, when you see the symbol, this is referred to as evaluating f in this value, in the square root of 2. I mean, there are several ways you can read this. You can read this as evaluating f in the square root of 2, or calculating f of the square root of 2, right? I mean, that's actually how we read it, f of the square root of 2. I mean, there are several ways, guys. There are several ways. Try to, you know, when you hear me, referring to the same thing in different ways, try to make mental notes, because yes, I mean, in mathematics, just as in normal language, we can say the same thing with different phrases, and that may be a little complicated at first, but you will eventually pick them up, all of them up. So let's see. This is my function, and they want me to find, or to calculate, or to evaluate the function in this particular input, the square root of 2. All I need to do is replace, when in this expression, whenever I see the x, I just put this value. That's it, guys. And that's it. I'm technically done. This is it. If you did this, it's perfect. It's perfect. There's nothing else to do. I mean, if you continue the process and elevate this to the square and got 2, and then you did this, it's okay. It's also okay. But even doing this is perfect. That's what I want you to understand. And then B, find f of 2/3. Same idea. 2 times 2/3 to the square minus 2/3. And that's it. You're technically done. Because if you notice, guys, in instruction, I'm only telling you, find the value of the function in this particular value of the input. I never told you, like, and simplify. I never gave you this phrase that would mean that you need to simplify as much as possible, like do this type of process. No, I mean, so this is perfectly okay. Anyways, let me continue. Let me continue simplifying. So you will be getting 2 times 4/9 minus 2/3, and then this is 8/9 minus 6/9, and then this is 2/9. So yeah, I mean, if possible, simplify. It's always better to simplify a little bit, but realize that by doing this, you're technically answering the question correctly. And if a teacher says that this is wrong because you didn't simplify, you can reclaim that. You can appeal. You can say, like, well, you never told me to simplify, so this is perfect. And you would be correct. You would be correct. So it's 2/9. Find f of a plus 1. F of a plus 1, same idea. I mean, really, guys, these three things is the same. It's exactly the same. That's it. I'm done. I'm done. If you went ahead and I'm sorry, if you raise this binomial to the square, a squared plus 2a plus 1 minus a plus 1, that's cool. That's cool. But this is okay. I'm just gonna stop right there. D. Let's take a look at D. So D tells you, find the value or values, either singular or plural. Find the values of x for which we get f of x equals 1. So this is the reverse problem, right? In here, I'm giving you the value of the output for a specific input of x. So basically this symbol, guys, can be read in this way. For what x, question mark, for which x, do we have that f evaluated in such value will be 1? You see? So for what value of x do we have that f of x is equal to 1? And basically all you have to do is this. If f of x is equal to this, then just put it here. That's it. And obviously solve the resulting equation. 2x squared minus x minus 1 equals 0. Probably this can be solved by factorizing. Let's try it out. This is the factorization of this trinomial. Yes. And by now you should be acquainted or familiar with this process, right? If the multiplication of two numbers is 0, that's because the first number is 0 or the second number is 0, and that means in return that in this case 2x, well, basically you solve this equation and this other equation, and by doing such you will be finding both values of x. So x is equal to minus 1/2 or x equals 1, and this is it. These are the two values. These are the two values that will make the function being these are the two values of x which will produce this output. If you put either minus 1/2 in here, you will be realizing that all of this is 1. Or if you put 1 in here and in here, all of this is going to be worth 1. And that's it. That's how you solve this particular question. E. Is there any real value of x for which we have that f of x equals minus 1? Well, this is similar, right? Similar as before. You see? They're asking me the same question. Well, not the same question, a similar question. Like, if I ask you this question, is there any value of x for which the function has this particular output? What you do is you investigate that problem. Once again, if f of x is equal to this, just write it down once again. Make it equal to minus 1. Try to solve the equation. We have it like this. You won't be able to factorize this thing. You won't be able. So what you have to do instead is make use of the general formula. And the general formula, after you write it down, it's gonna look like this. Make sure, please. Make absolutely sure of what I'm telling you. It's gonna look like this. So, I mean, apparently everything is okay, right? But there is a problem hidden here in this radicand. What is the problem? The problem is that when you do this arithmetic, all of that arithmetic will go down to 1 minus 8. You see, you're gonna be trying to calculate the square root of 1 minus 8, which is equal to the square root of minus 7, and the whole thing breaks down because we cannot calculate the square roots of negative numbers. So what is my conclusion? That's what I'm trying to. I mean, what is the conclusion of this? The conclusion is that we can't, or that there is no value of x for which f of x equals -1. Period. There is no value of x, and this argument is showing me or telling me that solution. There is no value of x for which we can have that f of x equals -1. F. Which of the following sets of ordered pairs might represent the function f? Neither. Neither. And by the way, let me be honest with you guys. I didn't when I did the exam, when I wrote it down, when I made it, I never intended for this question to have no answer. Like neither of these sets, neither of these represents the function. But that's not what I was trying to do. This was an honest mistake. If you consider, I think we can erase. Yeah, let me erase the whole thing. I mean, let's go back to my function. There you go. If you consider these inputs 2, -1, 4, and you evaluate the function in those inputs, for example, f of 2 is equal to this. That's going to be equal to 8. That's going to be 6. Okay. So for 2, I get 6. So this is a correct point. But one of these two fails. I'm not going to do the whole thing. I'm not going to do the whole thing. One of these two fails. So this set does not represent the function, because when you evaluate in either -1 or 4, you do not get this input in return. So this does not represent the function, but neither this. Like for one of these inputs, you won't be getting its corresponding output, which was not my intention. So it's neither of those two sets represent the function. Although, now that I think about it, it's a good thing that I made a mistake, because I mean, you should understand that probably the questions in any given exam might be wrong, and you can argue that. Like, I mean, most of you argued, like you said, neither of these sets represent the function because blah blah blah, period. And that's okay. That's perfect. And letter G, which of the following graphs represents the function f? All that you had to do in here is basically take notice of some rather obvious points. For example, if you look at this graph, you have this point, which is clearly -1, 0. You have this other point, which is 0, 0. You have this other point, which is -1, -2, right? Remember, this is input, output, input, output, input, output, and just try them out. Like if this, like what I'm saying is this: if this is the graph of this function, if this is the graph of this function, then each of these 3 points and all of the rest, although it's not clear, for example, I mean, well, this one is also clear, -2, 2, but for example, the points in between may not be as clear. But these ones that are obvious, that are very clear, each of these points, each one of these points should satisfy this function. What do I mean? I mean that when you evaluate in -2, okay, and when you do this whole process, then you should be getting 2. Okay, so all of this should be 2. And if all of this is not equal to 2, then you can be sure that this is not the graph. Okay, each of these points should satisfy this equation. Okay, and that's how you find out. And if I'm not mistaken, it was either this one or this one. I can't remember. It was let me. 2x squared. I think it's this. I don't want to do it. It's just, it's either this or this, and I think all of you got it right. So I don't want to do that stuff. It's definitely not this one. Definitely not this one. Okay. I mean, you can go to Desmos and just look it up yourself. Just type in the function and realize whether it's this or this, and that's it. Although you were not allowed to do that in the exam, clearly. 7. Find the domain of the following functions. I give you 5 functions. I'm gonna do this very quickly because I'm getting tired. This one, the domain is all the real numbers. All the real numbers. Why? Because this function never breaks down. It never crashes. Remember when I say this, guys, this is not mathematical phrasing or mathematical standard vocabulary. This is just so that you can understand what I mean. It's a metaphor. So if you give x any value, it doesn't matter, pi, 1/2, 3, whatever, this function will never crash. And by crash, remember that what we mean is divisions over 0, something like this, or trying to calculate square roots or fourth roots or sixth roots, even roots of negative numbers. These are the only two types of crashes or problems that we can run into. And this function is very well behaved, so it's a very decent function, and it's just the real numbers. What about this? What about this? You have the square root of x plus 1, right? And you can see by inspecting this radicand, you can see that you can give x any value greater or equal than -1. If you want to plot that in the real line, you have x, you have the 0, you have -1, you have -2, 1, 2, and if we give x any value from here onwards, then we will be safe. And if we give x any value below -1, that's going to cause a problem, and this is cool problem. Just make tests. Just make tests. I mean, does this work for x equals -1? Clearly it does. You see? The square root of -1 plus 1 is equal to the square root of 0, which is equal to 0. So it does work. It does work. Now give any value a little below -1. A little. Anything below -1, and this will crash. Give x any value above -1, and this will be safe. And that's it. That's it. What is my domain? This is my domain. All the real numbers. Well, I mean, remember, we can do it several ways. I can do this. All the numbers from -1 till infinity. Okay. You can write it in words like all real numbers above or equal to -1. This is perfect, absolutely perfect. Nothing wrong with this. And I mean, that's it. Or you can just write this, right? The domain of G is equal to all x greater or equal to -1. Several ways to say the same thing. Just be creative. Done. This one. Just by looking at it, you can see that we have the x in the denominator, so we run the risk of dividing over 0. And in fact, when x is 4, if x is 4, then all of this will be 0, and this will be exploding. So that's it. This is the only value that we should be aware of. So the domain of H is equal to all the real numbers except the number 4. Okay, another way, is all the real numbers from minus infinity to 4, excluding union 4 until infinity. Okay, well, when I write this, basically I'm leaving out the number 4. That's the only number. It's basically all of these means all the numbers except the number 4. You see? This one is very similar to this one. The only difference is that, well, let me clean this up. The only difference, let me write this down. There you go. Once again, we have the possibility of dividing over 0. If all of this is 0 for some specific values of x, then we have to reject those values of x from the domain of t. So let me ask that question. Let me ask the question. Could there be values of x for which this expression is equal to 0? I'm asking this question, guys. When you set down an equation, it's kind of like asking a question, right? Like, for what values of x is this equal to 0? And you can see it in the perspective of a question. And then you go on and try to solve it. And if you can solve it, then that means that there is in fact some numbers for which this is equal to 0. Same idea, let's try some factorization. Okay, and this one does work. And I'm not gonna do the whole thing again, like the whole solution. This is simply x equals minus 4 or x equals minus 1. And this is, but by asking this question, this is the response that you get out of logic. It's kind of like logic is telling you, yes, your question has an answer. And these two values of x will make this expression equal to 0. And you can just try them out if you're not sure. Like, give x the value of minus 4 in this expression, and you will notice that it's equal to 0. And the same for minus 1. So what is the conclusion? The conclusion is that the domain of this function is all the real numbers except the number minus 4 and the number minus 1. And all the stuff that I just said, like with words, all the real numbers except the number minus 4 and the number minus 1, if you write them down in words, that is perfect. And this one, f of x equals 1 over x squared plus 1. By having the variable in your denominator, you may be thinking, okay, there is the possibility of dividing over 0, so I need to be cautious. Now realize that when you observe or analyze in detail this expression, you should notice that this cannot be equal to 0. This cannot be equal to 0. It's impossible. It's impossible. Why? Because x squared, no matter what x you put in here, no matter what x, doesn't matter, positive, 0, or negative. When you add 1 to a number to the square, you will invariably end up with something that is positive. Because when you consider this thing, the least value of this is 0. Like if you see it from on an axis, if this is the number 0, and then you have positive numbers and negative numbers, the least value of this expression is here. This is the floor, and from there upwards. You see, this thing cannot have any of these values, which is quite clear. And therefore, that's it. That's the only argument that you need to produce. If you tell me all the stuff that I just told you about this, and if you want to rewind the video and pay attention to the words that I say, any argument similar to the one I gave you, like, well, the domain of this thing It's going to be all the real numbers because x squared plus 1 cannot be equal to 0 because x squared blah blah blah, you see, then it's fine. It's fine. Okay, so the domain is all the real numbers. We don't run the risk of dividing over 0 because of this exponent. This exponent saves us from such problem. Okay, let me take another pause and so we can finish the exam. Okay, and finally we have this last problem, problem number 8, which reads as follows. The distance that a car travels, d, in kilometers, and the time spent driving, t, in hours, are related through the equation d equals 60t. Let me expand the whole thing. Does this relation represent a function? Argue your answer. Well, let's see. The answer is yes. The answer is yes. What is the argument though? The argument is that for each value of time, that we can put in here, we will only get one and only one. This is the key phrase, guys. Never forget the idea. For each value of time, we get one and only one value for the distance, according to this equation. It's impossible. It's impossible that when you give t any value, let's say t equals 1 hour, and then you compute the resulting value of d, then you will have d equals 60 times 1, which is 60. That's it. One input, one and only one output. And by the way, yes, I'm considering t as the independent variable, the one that we manipulate. I'm considering this as the input and this as the output. So that's it. It's impossible that one specific input can have two different outputs, such as 60 and 120 at the same time, not according to this equation. Maybe for some other equations, that's going to be the case, not for this one. Therefore, is this relation a function? Yes. Yes, it is. For the reasons that I gave you. Express this relation through functional notation. Okay. So what is my input variable? My input variable is t. What is my output? D. And there are many ways. There are many ways you could have answered this question. Probably some of you did the following: f of t equals 60t. This is okay. Maybe some of you did this: d of t equals 60t. This is also okay. In this case, I'm calling the function f. This is the name of the function that links the time and the distance. Remember, if this is the set of time and this is the set of the distances, then what this object, the function, is doing is linking or mapping or transforming one value in the inputs to one value in the outputs. It's a transformation. F, which is the function, is the object, is that abstract object that maps this value into this one, and this other value into this one, etc. It's kind of like a linker, okay, a transformer, a machine. And this machine can be named anyhow. It doesn't matter. Most people use f for the name of the function, but if I'm talking about, if basically what this function is doing is giving you the distance for a certain time. You see, we have time, and this thing will give you the distance. Then it could be a very good idea to call it d. Okay, because basically, if you think of this as a machine, okay, and we call it function d for distance, then you put any time, and this machine, the machine distance or the function distance, will give you the distance for that specific time. And it's perfectly okay. So in this case, just don't make the mistake of confusing this d, which is the name of the function. Probably in order to avoid confusion, we should have capital D, just to make very sure not to get confused. So this is the name of the function, the name of the machine, and do not confuse that d with the variable, d, which is the variable of the outputs. This is a very hard idea to understand, guys. Kind of. I mean, I remember myself going back to high school or even college, and I couldn't fully comprehend, or I don't know. I thought there was something kind of confusing between labeling the function the same as the output variable, and it is kind of confusing. If you want me to talk about that in detail, just make me know. So done, done. And calculate the number of kilometers traveled when t equals 3. When we have traveled for 3 hours. I mean, come on, this is extremely simple. And oh, by the way, use functional notation for this. So if my function is this, I'm going to use f. Okay, then just input the value of 3 hours into the function, and the function will tell you the corresponding distance. For 3 hours of traveling, you get a distance of 180 kilometers. And D, calculate the number of hours that have been spent driving if you know that the distance traveled is equal to 80 kilometers. I don't need to add kilometers here. You may be thinking, teacher, you should add the unit. No, no, because I already expressed that idea at the very beginning. I told you the values of D are given in kilometers, and by doing this, I don't have to keep like reminding my reader that this number represents kilometers. I already did it once. If I put kilometers here, that's cool, but I don't have to, because I already did this and this. And well, this is the reverse, right? If this is my function, and if I know that the output is 80, since this is the output, then just input 80 and solve this equation. You get this. That's it. 1.5. That's it. That's it. Okay, so this solves the whole problem, guys. As you can see, it took me 1 hour and 24 minutes. So that was, and I mean, you need to be aware that I explained with excessive detail with, I even went on and explained things that I should not explain to you, right? Like, I make a lot of commentary. That's what I mean. So it was perfectly doable in 2 hours, which was the time for the exam. So I hope you learned something by either watching the full exam being solved or just any particular problem that maybe you couldn't solve. Thank you very much. See you later.